Hello, maths fans. We're going to be looking at a pretty tricky question here. It's a six-mark question on arithmetic sequences. I recommend pausing this and having a go at it first, and then seeing what you do know, and then playing slowly through, giving yourself some hints to try and do it interactively, rather than just sitting back and watching how it's done. But anyway, here's how we're going to go about this. So the 8th term of our arithmetic sequence is double the value of the 3rd term. The 5th term is equal to 14. Well, I like to see things visually. So let's think about this sequence. We've got 1, 2, 3, 4, 5, 6, 7, 8. Here's our first 8 terms. I know that the 5th term is 14, so let's put that in there. And I know that the 8th term is double the 3rd term. Well, let's call them 2x and x, because 2x is double x. That's about as much as we can say for that. What we also know is this is an arithmetic sequence, and so to go from one term to the next, I'm always adding the same thing, plus d, plus d. Let's remember that and keep that in mind. I think that by making these little notes, it helps to clarify what the question's actually asking. Right, we need to determine the first term, u1, and the common difference. We're looking to find d. Well, we haven't got a lot of information here, but what we do know is that to get from x to 14, I must add d twice. To get from the 3rd term to the 5th term, I'm adding 2d. So x plus 2d equals 14. That's useful information. And I also know that to get from 14 to 2x, add 1, add 2, add 3d. So 14 plus 3d equals 2x. Well, that's enough information to form ourselves, well, we've got ourselves a simultaneous equation. So, if I line these two equations up, maybe just move them so that they're a bit more convenient. Let's make it x plus 2d equals 14. And then the other one, let's just tidy it up and make it 2x minus 3d equals 14. All I've done is I've taken the 3d away from this side and brought it to this side. Now, in order to cancel out either the x's or the d's, let's double the top equation. Let's multiply all of this top equation by 2. So I'm going to get 2x plus 4d equals 28. Times 2, times 2, times 2. Now I'm going to ignore that top equation and use this new one. Let's call this a and this b. And I think I'm going to go for b minus a. 4d minus 3d is 7d. Be very careful when you're subtracting a negative. And 28 minus 14 is 14. Well, divide by 7, I get d equals 2. So, the common difference is 2. That's good. I can now work out pretty much everything else in the sequence, I would say. I can go back here, take away 2, take away 2, take away 2, take away 2. But before I do that, I think I'm just going to find x. Well, do I need to find x? I could find x by substituting d equals 2 into any one of these equations. But actually, I don't think I'm going to do that. I think I'm just going to go straight to finding what the first term is by subtracting 2, subtracting 2, subtracting 2, subtracting 2. In this particular case, I think that's going to be the most efficient thing to do. So I'm just going to get 12 here. X will be 10. Then we've got 8. and then we've got 6. And that's all I need to do. I found that u1 equals 6, and my common difference equals 2. There are other ways to solve this one. As I say, once you've found that common difference, you could substitute it into one of these equations. Maybe we could say x plus 2 lots of the common difference. I'm substituting into this top equation, equals 14. So x plus 4 equals 14, x equals 10. And then I can say that I've found x as well. Perhaps the question's asking me that, but in general, I think we've got to a solution, so we'll leave it there.